Okay, we're actually live. Welcome to the Bytecode. I'm your host Shafu, and today's episode is with Will, who's gonna walk us through Tevm, TEVM. Will, thanks for taking the time, man.
Yeah, thanks for having me. I'm excited to show you through this code base, nerd out on JavaScript a little bit.
Let's do it. So, yeah, maybe start by giving us a brief, high-level overview of what Tevm actually is.
Yeah, so Tevin kind of came originally from just like being a Solidity kind of like front end dev. I've always been on the front end, even though I've kind of been in this space since 2018. And kind of like wishing that I had some of the tools that are available for you outside of JavaScript, like in the JavaScript land. So it's really inspired by Foundry more than anything else. I think the original kind of ideas for Tevin came up when I was using Foundry for the very first time. And I'm not much of a Solidity dev at all. I've written contracts, I've read contracts. I can kind of like donk my way around Solidity contracts, but I'm not an expert at all. But what really impressed me about Foundry was that even myself, as someone who writes JavaScript, is very fluent in JavaScript, like feels the most comfortable in JavaScript, I actually had a much nicer time like writing Solidity tests in Foundry than in JavaScript. And that kind of got my wheels spinning a little bit about like, is there any way I can kind of take some of these ideas from Foundry and like use them to make my ability to build like front end applications or even test my JavaScript apps like a lot better. And that's kind of where this came from. So if we look in, this is kind of in the README. If we look at this example here, this is a really minimal example that shows like a lot of what you can do with Tevin. So what you might notice on the very first line is I'm just importing a contract directly from a Solidity file into a TypeScript file. And we'll see later actually that this is completely type safe. When I hover over this, you'll see like nat spec comments. It will show you the complete interface of the contract in a human readable way. If I even go to click on this balance of, which I can't do here because we're in a README and not an actual code file, but if I were to double click on this, it would actually take me to the Solidity contract where balance of is defined. So this is just making like using my contracts in TypeScript a lot nicer because I don't have to like set up complicated build pipelines. I don't have to worry about like copy pasting ABIs. I don't have to like when I change the contract a little bit, I don't have to like worry about did I rebuild or not. Because it's kind of this allows it to be built directly into the TypeScript build process. And then the second piece of this is kind of like I think of that as being like the JavaScript version of like Forge build. Um, so then the other power of Foundry, I think, so another power of Foundry is kind of Anvil, right? Like the ability to have a DevNet, and and this is more powerful than people think on the front end. So like I'll just like give like a quick example of like a problem where like I wish I had Anvil on the front end. Um, if you want to estimate gas for like a token, something like a transfer from of a token, this is like kind of my canonical example. Um, you actually like can't easily do that until the user already approved. And the reason that that is because if you send a ETH estimate gas request before they approve, it's just gonna be testing against a reverted transaction and won't be able to estimate gas. And you can fix that with like state overrides. Like there's like fancy ways you can get around that, but it's not like super easy or ergonomic, and most people don't ever do that. But you could imagine if you had Anvil like available to you, like in the browser, you can literally just like impersonate the user, approve the token, and then estimate gas. So like little problems like that become really easy to solve. Another problem that came up, I think, that's really common that a lot of the users have been coming to me for is sometimes they just need to like replicate contract logic on the front end. So this is like really common where like they'll write a contract, they might have some like complicated logic in it to do anything you can imagine. You're shaking your head, so I'm sure you can think of examples of this. And what like people don't want to do is they don't want to have to rewrite that logic in JavaScript and then like keep it in sync with their Solidity. You can so like there's a lot of code reuse power if you had like quote unquote Anvil in your browser, because you can actually just execute the Solidity. You don't have to rewrite it in JavaScript, and that's pretty powerful in terms of code reuse. So sorry if I'm going a little slow here. I just want to make sure that this is kind of like a new way of writing JavaScript. So I want to make sure like kind of the use cases make sense before I kind of dump the features onto everybody.
No, it's great, man. It's great, and yeah, I was heading my, I was agreeing totally because this the example of having logic that you have to re-implement the script. I did this a couple of times, and it
Mm-hmm.
sucks. So this is
Yeah.
definitely a great solution for this.
Mm-hmm. Yeah, exactly. Yeah, and I used to work at Optimism too, and I can think of a lot of examples there where um, we had to do a lot of work of like rewriting, like for example, how we hash L2 to L1 withdrawals, for example. Like we have a Solidity contract that does that, but then we also have like a JavaScript SDK that does that, and um, that's like another example of that kind of like made me think like, oh, this is a problem worth solving. So yes, with all that introduction, yeah, that's what this memory client is. So this memory client is like kind of the Anvil part, where if you call create memory client and you can even fork just like Anvil, like what I'm creating here is basically a Ethereum nodes very similar to Anvil in JavaScript that can run in the browser, in Node.js, or in Bun. So any problem that you've ever wanted to solve, where if Anvil would solve your problem, it's pretty easy to use it. You just use this memory client to solve it. They're pretty lightweight, easy to spin up. Um, and yeah, they basically just execute bytecode. That's like kind of they execute bytecode. They simulate the blockchain. You can like mine blocks and stuff like that. And then here you can see I'm just using like a basic action. So if anyone's used VM, so this whole library is actually built on top of VM and ABI type. So the API for interacting with this memory client is actually just like the VM API. So you can do like any VM API you can think of, like client dot get block number, for example. Like every VM API is supported, so you don't really have to like learn a new API to use this. Um, and it also works. It's very modular. This memory client, there's adapters to, if you prefer Ethers.js, there's an adapter to plug it into Ethers.js. You can use it with pretty much anything. So I would say there's more, there's a lot more in Tevm, which we can go over, but those are the definitely like the main features, and anyone can like kind of go to the Tevm repo and read the README and the docs for more, or watch the rest of this for more. Does that everything make sense so far? Um,
Yeah, it does. One question. So basically, there's an implementation. There's a JavaScript implementation of the EVM,
mhm,
which runs in the background.
mhm,
And also, WAGMI is VM. WAGMI is based on VM as well, right? It's also using
mhm.
it in the background.
Yep.
Okay, okay.
Yeah, yeah. This works with WAGMI too. So you can actually plug this memory client into WAGMI via, they call them transports. Um, which is a transport is just like how do we like transport the JSON RPC requests to like Alchemy or to whatever your node you're connecting to. You can actually plug in Tevm in as a WAGMI transport, and then use it kind of like use WAGMI too with Tevm, and it works perfectly fine. So that's actually another use case is you can, it's built specifically for VM, but because WAGMI is built on VM, it's like built for WAGMI too, which is nice. I get that for free. Yeah, and I wanted to show off just because I watched a previous episode where someone kind of showed off the CI/CD, and I don't know if people like that, but I liked it. So I wanted to kind of show off kind of just like how the Tevm repo works, and in doing so, we can actually like dive into the smaller pieces a little bit.
Let's do.
Yeah, so at a high level, it's a PNPM monorepo. So if we go to this workspace YAML, it shows where all the packages are. So most of the VM packages are in this packages star folder. Um, so you can see them all in here. It's pretty modular how it's broken down. So every internal package Tevm uses is actually available as a standalone package. So you can use the high level API, which is documented nice, easy to use. But if you kind of want to get your like hands dirty or like wish that you had like lower level control, you can definitely like dive into one of these packages. For example, this EVM package is just like the EVM interpreter, and nothing else. So like if you wanted to just like if all you wanted to do is just use the EVM, you didn't want to like blockchain or you didn't want any of the VM stuff or any of that, you could use this. Yeah, and then the other main packages are actually in bundler packages. So bundler packages, this is what kind of does the Solidity import magic. The base bundler is the main package that does that. So basically, if we go in here, the way this base bundler is actually used to build support for everything else. So basically, the way this works is it just has functions on it like resolve DTS. So that means like resolve TypeScript types, or it can resolve CJS, which is just like turn it into like common JS, JavaScript, and stuff like that. So this bundler is basically used to create every other bundler. So that's how the bundler works with pretty much like any other build tool. So it works with like ES build, rollup, RS pack. Another cool package in here is the sol-c package. I mean, there's not much to this, but the sol-c package is just, I could imagine people wanting to use this if they want to use sol-c, where all it is really is just, it's just sol-c, but with TypeScript types. So sol-c, like by default, doesn't have TypeScript types. I'm a bit of a type maxi myself, so I wrote TypeScript types and then wrapped it. And that's so like if you wanted to use sol-c and have like stronger typing, this is available for people to use. In terms of CI/CD, I really like this a lot actually. So if I exit really quick, so my favorite thing about the way I do CI/CD in here is I have this one file does all my CI/CD. It's like it's pretty magical. So it uses a tool called NX. So actually, if I back up really quick, NX is like a monorepo tool. So I can do like NX build types at Tevm memory client. And then when I do this, it's like smart enough to figure out like what packages does it depend on, and it will like build if it has any dependencies, it will build those dependencies first, and then it also like caches. It has really smart caching and stuff. So I'm gonna actually end this, but if I go back, so the way the CI/CD works is I actually just like I can horizontally scale it. So I scaled it to like 12 boxes. So when I run the CI/CD, it will like spin up like 12 boxes in GitHub Actions. And then all I run is I basically just like say like, hey, I want you to run like all of this. Like I don't have to like build the pipeline myself. I just say like, hey, these are all the builds and tests and linting. I just want you to do all of this. And then what it will do is it will, because it can figure out the build graph, it will actually smartly like basically pick jobs off the top of like what's the first job I have to do, and like kind of give it to whichever like machine is ready next. So like it allows my CI/CD to be pretty fast and have like really good caching basically. And you can see like this would scale to like a team of like 100 or more devs pretty easily. And you can see it's basically just like one 82 line GitHub Actions file. So I really love NX for this reason. Is it basically gives me like extremely good caching, extremely fast CI/CD, and a really good CLI tool. With like almost like no complexity on my side, which I love. Yeah, I can show off just like trying to use Tevm a little bit too. So if I go into the playground really quick, I can show off just some of the features. So like for the Solidity imports, for example, you can see if I hover over here, wait, I don't have any NatSpec comments in here. So if I add like I think that's how you do a NatSpec comment. Sorry, I'm very bad at Solidity, but I think that's how you do
it. You need 3 slashes.
Oh, you need 3. That's right. So if I add 3, let's see if it works now. There it goes. Yeah, you can see like the NatSpec comments show up when you hover over the contract, which is quite nice. And then you can also see there's like this human readable API that's inferred from it. And the other cool thing is actually when I added that NatSpec comment, I don't even have to save. The LSP is actually smart enough to see the changes before I save, which is if you're like developing contracts and the UI at the same time, that's like kind of useful, because if you like, make a breaking change to the contract, you'll immediately see like all your red underline show up in TypeScript.
Yeah, well, I have a question here. So, okay, for the Solidity part, is it using the one LSP that everyone is using, or is this a custom implementation as well?
Yeah. So I think the one most people are using now is from Hardhat. I forget what it's called. It's not using that. It is using a custom one that I built that's like really minimal. It's just built on top of Sol C. And I forget what the other library is, but there's a library for getting like the AST and navigating the AST in Solidity. So it's pretty minimal. It's just using that. I actually have talked to the Hardhat team, and I want to like migrate to using their LSP in the future, just because I think it will be like a lot better to maintain. And it should be able to plug in pretty well. The only thing with theirs is like basically like theirs is like built for Solidity. So I would still need pretty much all the same plumbing I have now in terms of like getting TypeScript to recognize it, but it would allow me to add more features than I currently have. Like there's features like I want to add, but they're like a little too complex to add, if that makes sense. Whereas if I just leaned on like Hardhat's LSP, I would be able to add those features pretty trivially, because they just have like functions to do that stuff. So I do want to do that sometime, but like yeah, currently it's just like a really minimal, like built with like the lowest level primitives, which is just Sol C.
Interesting. Yeah, I'm asking because I'm also using NeoVim, and the Solidity LSP isn't working for me, and for the life of me, I cannot fix it. And I know several other people who have the same problem. So
yeah. Solidity LSPs have a lot of problems. So like one thing that I do that hacks around one of those problems is like there's this versioning problem. I think you've probably seen before, where it's like if you don't have the exact Sol C version, specifically like in your pragma up here, like if you don't have
exactly.
If this doesn't match your LSP, like everything blows up, and that's just really annoying. Tevm has no one's like noticed this hack yet, so like apparently it hasn't caused problems, but I do a hack to make that a little bit better, where when my LSP reads this file, it will actually like change this pragma to be like whatever I want it. I don't know, I forgot what I made it, but it will literally change it, which is not like,
oh, this is dangerous, man.
It doesn't do that when it compiles, I should say. It does that only to like, it does that only to get the ABI, if that makes
Ah,
sense.
okay.
So like it
Okay.
usually won't cause problems, but like that is like a little hack I did, because without that hack, it would immediately have that problem where like you have to like match your versions or everything blows up. So it's
Mm.
like a bit of a trade-off, but um, yeah, I have an experimental package too that me and some other dev were working on, where we were trying to also make it just like really smart at like downloading the correct Solc version as it goes, but that's like a little more complex, would take a while to implement. So that's not like really ready to be used yet, but yeah, LSPs are tough actually too. They're generally tough to build. They're tough to build
Hmm.
performant in a
Interesting.
performant way. So yeah.
Why? Well, why? I never built one. It's interesting. Why is it hard?
Yeah. So, yeah, actually, let me go back and let's look at the LSP. Um, all right. So when I actually go in here, actually, I have these are unused, by the way. Um, I'll show these really quick. This would be an interesting way to build an LSP, though. This is using this thing called Volar, which is like an LSP framework. This isn't quite ready yet, but I was experimenting with that. It'd be interesting to build an LSP with like a framework for building LSPs, because it makes it like a lot easier to build one. So it might be easier to like build like a super robust one in Solidity if we use that. Um, but I'm not sure how that will work out. But if we go to the actual LSP, we can actually kind of see how it works. So this is like the entry point to the LSP, and this is specifically for TypeScript. So the way the TypeScript, have you ever heard of the decorator pattern?
Yeah, like the decorators in Python, for example.
Exactly. Yeah. So basically,
Yeah.
like what a decorator is basically like you give me an object, and then I'll like add additional functionality to it. Like I might add a new method. I might like modify a method to like do some extra stuff. So you can imagine like a logging decorator, for example, where like I just
Hmm.
like log the input and output, but otherwise just called underlying things. So that's actually how TypeScript plugins work. Is they hand you the TypeScript LSP object, and then you're just allowed to, and then you just have to return a new one. But when you return a new one, you're allowed to like add additional functionality. So that's what I'm doing here is I just read the config. Um, if you have one, a config isn't necessary to use it, but if you have one, I read it. Um, oh, this is interesting. So I create something called a file access object. Um, you can see it looks like FS. Like it's just a thing that can read a file, et cetera, et cetera. The reason I don't like use like import FS to do that is because this allows it to work like get files from anywhere. So it can get files from the LSP, which is that's how that magic worked before, where before I even click save, the LSP was already updated based on my changes. Or it would allow me to use this like in the browser, because all I have to do is fill in the interface for like reading and writing files, and you can like mock that in the browser. There's a cache, but then here's like the decorator. So up here, this create info, they have like a um, yeah, they have like a language service on it, and that's what we're decorating. So what I do is I basically just like pass in a bunch of decorators. So like if we pick one, um, we'll do this one, get script snapshot. Um, Basically what this decorator does is get script snapshot. So this is how an LSP works actually. So the way an LSP works is it has like an interface, and the interface has things on it like get script snapshot, or like get or like give me diagnostics. I don't know the name of it, but basically like you can just imagine everything your LSP does has like a specific like method on it, right? Um, and you basically just have to fill in this like common interface, and it's common for all languages. So here I'm modifying, this is the thing that when it sees an import, this is the thing that returns like what types that import should have. So what I'm doing here when I decorate it is I'm saying, okay, now instead of what you normally do, I want you to like, first of all, if it's not like a Solidity file, just like don't do anything. Otherwise, like, oh, you can see here, I only resolve the bytecode if it's a script. Otherwise, I only get the ABI. That's just like a performance optimization because getting bytecode is actually pretty expensive compared to getting an ABI. But all I do is just, and this is that bundler I showed earlier that works for everything. So it just uses the bundler, resolves the TypeScript types, and this will be like a literal TypeScript file that gets returned here, and I just like return the TypeScript file. So like that's like how I decorate it, but this is also how an LSP works. But now the problem with this is there's expensive methods, right? So if I go back, which one's the real? Oh, this one's expensive, right? So this is the one where like if I like hit GD in Neovim and it takes me to like where it's defined at. Building something like that is actually really hard to build efficiently. You can imagine, right? Because it has to basically like traverse your entire like AST graph to like find what you need to find. And like certain languages like Golang are like really nice because they just like ship with like all this stuff. Like the reason why I love Golang is and Rust and all these languages because like they just like ship with all this stuff. You don't have to like build it yourself. You don't have to like pick each third party you need.
Yeah, but I always thought, well, that it's basically indexing everything. But is it
Yeah.
actually doing it on the fly? I don't think so, right?
I mean, it depends on the implementation. So like, yeah, it often will just for performance reason have to like basically like index it. But this is also where you get problems, right? So like, anyone who's used TypeScript has probably had this experience, especially if you use VS Code, of like your type server just gets completely out of whack, and you have to hit like restart TypeScript server to get everything fixed. Maybe you installed some node modules and just broke everything. So like it's like that's true, and then that comes with its downsides because like basically like because TypeScript is like hacks on hacks on hacks on hacks. Like this has basically just been like such a long-standing known bug in like VS Code that like at this point it's just like the TypeScript experience. Like any TypeScript dev knows like, oh, your TypeScript's not working. Have you tried restarting the type server? So like, yeah. So like it's basically like you got to pick your poison. Like, do you want like horrible performance, or do you want like complicated caching that's going to come with bugs? Ideally, you just want like something like Rust, where like it's almost like the platform itself is like really good at supporting it, if that makes sense. And that, yeah, I think the languages that like thought about the LSP up front, those are the nicest languages to use in terms of LSPs, like Rust, Golang, like all these. It's funny that TypeScript's not a good one because the language that actually invented like the common interface that's like the TypeScript, that's like the language service plugin is actually, it was like VS Code and TypeScript invented it. But I guess because they were the first ones, TypeScript's kind of like a struggle when it comes to that.
Oh, they defined the protocol? Interesting.
Yeah, it was actually invented by Microsoft in VS Code, but it became like an open source standard that like, you know, Neovim uses. So you don't have to use VS Code to use it, which is nice. I actually can't imagine what life was like back when programmers had to like not have LSPs. You know what I mean? I can't imagine programming without an LSP these days. But I think Solidity is way behind. I think
I'm doing it right now, man, because I'm doing Solidity and my LSP is broken. So yes, it's not the greatest thing.
Yeah, that's true. Yeah, usually when I write Solidity, I basically just write it without LSP until I get like stuck. Like sometimes I'll get stuck and I'll be like, I need an LSP to be able to like figure out like where all my bugs are and all my syntax errors are and stuff. But,
Yeah.
Yeah, I'm trying to think because I could go deep into the LSP land. I'm not sure how deep we
Yeah, this was an interesting detour, but I would love to build something in Tevim. You want to build
Yeah,
something?
let's go back.
Or look at an example or something. I think that would be fun.
Yeah, so this playground, I have it like set up with the stuff that would be hard for me to do. But this is an example that people thought like kind of blew people's mind what is possible. It,
A
and I
server.
built this before,
Nice.
but we can like build it again from scratch. We'll see how far we get because it might be hard to like iron out all the bugs. But what I built before to kind of like show off Tevm, I don't know. First of all, before I show this, I should like disclaimer. I don't know if this is a good idea, right?
It
This is
isn't.
a fun idea.
It isn't.
This is a fun idea. I don't think I would use this in production. I have no plans to like make this like a Tevm library that I want people to use, but it's really good at showing off like how powerful Tevm
Yes.
is at TypeScript and Solidity interfacing. So like what I built here or what this interface is and what like we can try to like get this to work with Tevm is basically this is just like a server with like a made up API that I made up of like how it could work. Written in Solidity, right? So the idea here is like we want to write servers in Solidity. Solidity is the best language. It's better than Golang. It's better than Rust. We want to write servers in Vitalik in the God's language, right? We want to write. That's how we want to build it. So you can actually do this with Tevm, right? Because Tevm has the ability. So before what we showed is like you can run like Solidity scripts in JavaScript. But Tevm equally has the ability to run JavaScript in Solidity, right? So you can
Oh,
see
I
like,
didn't know that. Well, that is huge, man.
yeah, and it can do it in a type safe way that we'll see in a second. So like,
You should say that when you present it on a high level. Yeah, this is wild. Okay, so
yeah.
okay, I would love to see this. Yeah. Let's call some TypeScript stuff in Solidity.
Okay, cool. So you can see like the made up API. The way I imagined it work is basically like you just pass in addresses to these like request and response contracts, and then you can like set the header, set the body, and send. Because I can't write Solidity, I went ahead and like wrote those up front, so I don't have to like struggle writing it. So you can see like this is step one. I guess what I'm showing here is the question like, okay, I can run JavaScript in Solidity. How? This is how. So step one is you got to write like an interface, and you write the interface in Solidity, right? So you can use it in Solidity. And then this will also click why did I spend so much time making it so you can import Solidity? You're gonna because it makes this a lot better. So if I go to run server, you can see I'm importing these, and then how do I get Java? How do I like implement these interfaces in JavaScript? I use this method called define precompile. So the way a precompile works, let me comment this out really quick, is basically you just give it the contract that you, so you import the contract, you give it the contract. I just added addresses to it, and this is a bug already. So I like said like, okay, the precompiles are at this address. I give it a contract, and then like you define a call method. I forgot actually even what is on this. So basically the call is like, it just gives you like the raw data of the call and the gas limit, and you just like, and you return, like you return like something like this, like data 0x gas used 428. Like you basically like that, this is how you like define one at a low level. But I also give you this other utility called define call. And what define call, and you can see this red underline, is the way this works is like when I give it the ABI, it's asking me to fill it out, and then this is type safe. So if I hit like this, you can see like this has a method that I should fill out called params address. So I can add that. And then this will get, if I remember correctly, it'll get like the param key, which this should be type safe. So it knows that param key. Yeah, no, oh, it's actually, I got my own interface wrong. So it gives you the gas limit, it also gives you the args array, and it's smart enough to know the args array is just gonna be like a single string. It got that from this interface. So that's extremely powerful in that, like, basically, like, defining that Solidity interface not only made my Solidity type safe, but also made this TypeScript code type safe. And then basically we just have to like return what the param would be. So I think the way you get a param is like, is on here, search params. And is it like .get, I'm guessing? You can see I can't program without an LSP, by the way. So arg0. I think it might have to be a string. So const address. And then we want to return, we'll just say this gas used is 0. And then we'll say is address. I think I have to turn it into bytes actually. So Tevm has a util for that. Hex to bytes. Or does it? Oh no, it's smart enough to do it for me. Let's go. Okay, so I underestimated how good I made this API. So it's smart enough to know that I have to actually return like a hex-based address actually, which is nice. So then I'll skip ahead in terms of just so I'm not like bearing the lead here, because I don't know how far we'll even get on this. But then the way that we use the precompile is when we create the memory client, which remember was like the Anvil running in JavaScript thing.
Yeah, Will, could you explain a precompile again? Because when I hear precompile, I always think of these 6 precompiles in Ethereum, if you know what I mean. These that 1 address, 2 address, 3. So this is a little bit confusing to me. What is a precompile exactly here? Okay.
Yeah, it's actually the same thing, right? So like a precompile in Ethereum, like what is a precompile? A precompile is basically like a contract on Ethereum that isn't necessarily running like Solidity bytecode. It is running like some kind of spec, right? So like it might be like, so that, for example, there's a precompile for 4844, right? For doing like 4844 like hash validate. Sorry, I'm not an expert on this, but like there's basically like a precompile of 4844 that like validates based on the KZG, I think it is, KZG commitments, like whether like a blob is like correct, whether like the hashing on a blob is correct. And basically what Ethereum is doing there is they're saying like, okay, here's the spec for like what should be happening at this address, but then like a client like Geth, for example, will implement that in Golang.
Yeah.
So it's basically like this. It is actually the same idea where like a precompile is basically like, hey, this is a contract that's not like a normal contract. This is a contract that like runs like code outside of like the EVM, if that makes sense.
I see, I understand. So basically you're defining something in TypeScript and basically throwing it at a specific address as a precompile, and you're putting that precompile into your memory client. So you can call into that.
Yeah. And also I should say this is also exactly how cheat codes work in Foundry, right?
Yeah.
So the way I landed on this API was originally what I wanted to do is I wanted to actually have Foundry compatibility. So I wanted to basically implement the entire like Foundry cheat code spec in JavaScript so that you can like run Foundry scripts in JavaScript. I still would like it if someone did this. So like I found out really quickly that would be really tedious and take me a long time. So basically, like I was thinking, like how can I like get this power quicker? And this is kind of the solution I got was like make something more generic where it's like you can just run arbitrary JavaScript, and then like what I would love to see is I would love to see like someone else who was like really like who really wanted to run Foundry scripts in JavaScript. Like basically what you could do here is you could implement the Foundry API such that you could now use Foundry scripts like in Tevm and use them in Foundry too. And that would be really, really powerful in my opinion, because it would just really help with code reuse. Unfortunately, it's like I said, it would be really tedious for me to like maintain that, just because Foundry's adding they add cheat codes all the time. In fact, cheat code is like if you want to contribute to Foundry, that's actually the best way to contribute.
That's funny, man. I did this like 2 weeks ago. I added a random function, but it isn't. But actually, someone else did it better than me, so they merged. They didn't merge my stuff in. But it was fun to look at for sure.
Yeah. I think Foundry is really cool. Like, yeah, I could nerd out. I'll try to stay focused, but I could just nerd out on Foundry for a while. I'm a huge fan. Yeah, so what that looks like is, well, that's sad. I'm not getting autocomplete there. From Tevm. That's bad. Oh, I never installed it. Tevm. That should go away. So yeah, basically you just pass it in here. So you would say precompiles. And then, yep. And then basically once you pass it in here, then you can call it from JavaScript or from TypeScript. I think it's called custom precompiles. Oh yeah, custom precompiles. And then I think, yeah, you have to call precompile. So like we could test this from like, if you wanted to like test this from JavaScript, you could call it from JavaScript too. So you would just basically do client dot Tevm contract, and then oh, this is another Tevm feature is we have these things called contracts, Tevm contracts. So that's what these are. These imports are actually Tevm contracts. You could create your own Tevm contract using like this, create script from Tevm equals create script. And this is what the compiler, the Tevm compiler is basically just creating these when it runs. So it's just like ERC20 maybe is the name. And like it will have like human readable bytecode. Yeah, something like that. This is basically what a precompile is, sure. Bytecode. But then, yeah, those are created automatically when you import Solidity, but you can create one manually like this. But the cool thing about these is, the reason why I made this is because it's like this common interface that you can use. It works with Tevm, but it also works with VM and WAGMI. So it's like that. Basically these contracts, and there's a way to use it with ethers. So these contracts make it so like when I call a contract, normally I would have to like, if you've used VM before, you have to like fill it out. Like you have to do like the ABI and then you have to do args. Always found that kind of tedious with the contract. What I could do here, if I wanted to like test the precompile, is I can do response precompile dot contract. And that's a Tevm contract. And I can do like, or actually, let me just do the response contract. I can do like read, or I think that one just has writes, write, and I can do like send. And you can see it's like completely type safe. Yeah, this works with VM too. So like if this is like a VM client, which it is. A Tevm client actually is a VM contract, or not a VM contract, a VM client. You can like, it works with VM too. So that's pretty useful. Yeah, we'll definitely not get through this by the end of the hour. By the way, I did too much like explaining and stuff like that.
No worries, no worries.
Anyways, I think I'm at least showing like how this is possible though. Is like,
Yeah.
you can see like, so you can see like what we want to do here is like we have this request precompile, and we want to fill it out. We want to fill it out with like based on the request, and we also want like this response precompiled. We want the response precompiled to like react to it. So like in the response precompile, I think there's like there's going to be like a set body. There's going to be a set body in here, and like in here we're going to want to do does this take a response, I'm assuming? Oh, we have to return it. Yeah. So we would probably have something like this. We would have like a response. Let's just make it any just to move faster really quickly. So we would basically want to do something like this, where we would do like response dot body equals. Oh, we don't actually even have to do that because it should be a string. So you can, so basically we would fill in this precompile, and then basically, and then what we would do is, and then one of them is going to be send. So like for send, what I would do there is, there's this new API called with resolvers. And you can do this, promise, resolve. So basically like before we return this response, we want to like wait for them to send it. So it would be like await promise. And then I'm kind of like pseudocoding here. And then whenever they call send, that's when we call resolve. And then here it would be like return new response, and it would be response dot body, and then there'd be like status response dot status, and then like headers, like response dot headers dot map dot blah blah blah. I'll just leave that out. But basically, like you can see like how quickly we can get to like this implementation actually working, and this at the end, I think when I built it before, it ended up only being like 120 lines of code, which I'll definitely like, I'll try to build it cleanly. Actually, now that we put this out, I'll try to build this cleanly and like get it like out there so people can actually like see like the working implementation, what it looks like. And like I said, I don't think anyone should use this. The point of this demo is just to show like the solidity to TypeScript interop is so good that building something crazy like I want to like build my front ends in Solidity. I want to like write like UI code, like React components in Solidity, or I want to like write a server in Solidity. Like all this stuff is like totally possible to do with Tevm. And that really is the point of Tevm. The point of Tevm, like if I like go way back, is just like, I'm sick of being blocked. Like that's basically it. It's like I'm sick of being blocked. I'm sick of like when I'm trying to build like UI for like a crypto app. I'm sick of having to like work around things that doesn't feel like I need to work around.
That's so interesting.
Tevm is like maximally hackable, and that's like the point of Tevm. It's like maximally hackable. You can like there's no like problem you can't solve with it.
Yeah, that's super interesting, Will, because I think. So I did both, you know, for Dyad, what I'm currently doing, like the stablecoin thing, I did most of the front end, and I did the contracts. But we also had people who did the front end and just, so currently we're at a point where it's really hard to work with people who are very good at front end stuff, but have no knowledge about smart contracts at all, you know? you at least have to know what an API is, you know, you at
Yeah.
least have to know what a test network is. So, but I think we can abstract that all away, and I think Tevm is could be one big building block of that. So, yeah, it's
Yeah, it's
interesting.
funny you said the ABI thing. So this isn't true anymore, but when I was first started building Tevm, I had a rule that my API has to be so abstracted that nowhere in my docs does it even mention that there's an ABI,
Mm,
right? Because you can get
yeah.
away with not knowing there's an ABI, right? Because you can just import this response object and then you can remember before, like you can just do like whatever the name of that contract was, request contract. Like whenever you do this, it'll basically, yeah. Whenever you do this, it'll basically like, oh, if that was a bug, because I called it I must have made it like not a view method, by the way, but yeah, like this will like return an ABI, but like at no point in here did you have to know what an ABI is. Like the
Mm.
compiler abstracted it from you, and then this like contract API was. I ended up going back on that, like because what happened was when I don't mention ABI, like people look at the docs and they're like, "What the fuck is this magic?" Like you have to at least explain to them what's happening.
Yeah, yeah, yeah,
Confusing, but
yeah.
yeah, I agree with that. And I think like another thing like is like myself as being like a bit of a noob because like I'm more on the front end side. I think like using Tevm actually teaches you a lot about at least, I mean it definitely taught me because I basically had to like build the EVM. So like now there's like so many EVM details. I've read so much Geth code. I've read so much like Foundry code that like I've really leveled up my like Ethereum nodes, but even if you just use Tevm, because like you have like access, like I can do this. I can say const VM equals memory client Tevm. This is like the secret scary API. Get VM. So like you have I actually oops, whoa, I don't know what just happened. So like going to that like Tevm's maximally hackable thing, you have access to like the lowest level APIs that I'm building Tevm with. And from there you can actually like learn a lot. Like I can go like VM dot like, oh, there's this thing called a state manager. I wonder what I can do with that. And then like you can look through this and you can be like, oh, there's this like idea of a state root. That's interesting. Um, set state root. And then like maybe later you'll figure out like, oh wait, if I do vm.blockchain dot like get block, let's do like, yeah, latest, whatever. Um, wait. Header, like you can almost like explore like the VM this way, like and like actually kind of like learn about it, which I think is interesting. I think this has a yeah, you can like do something like this. You can like manually, like there's higher level APIs for doing this, but like if you want to get your hands dirty, apparently this is only number, so like I'm gonna say like block 420n. So like you can like change, you can like revert the state back to like this state root, and you can learn like, oh, block headers have a state root, and like there's this thing called a state manager, or there's a VM. You can really like get your hands dirty with the EVM this way. And I think JavaScript devs are often like, you know, allergic to like Golang or allergic to Rust, so like they're not like as much as they probably should be like reading that code, because like if you read or something like I think Proto Lambda told me actually, he said like if you want to learn how Ethereum works is like go through the JSON RPC API and then go in Geth and just like kind of trace like how the code works, and he gave me that advice is like that's the best way to learn it. And I think he's right about that, where like I would encourage like any front end dev, any JavaScript dev, like to like not be scared of Rust and not be scared of Golang, and like maybe take some time to just like see like, hey, how does like an ETH call work in Geth? Because it's actually a lot less scary than you would expect it to be, and just like taking the time to kind of like learn how like the VM works, I think can like really help you a lot with understanding things, or even like things like logs, for example. Like I think there's a lot of devs out there, and I used to be one of them who like just like when you look at Etherscan logs, you don't actually know what you're looking at, right? Like what are
Yeah,
the
yeah,
values? And I think like that stuff can be like less scary than it needs to be if you just get your hands dirty with this. So like a hope of mine is that just because like this is so accessible for people to use, that people like eventually kind of get like diving deeper into like how the EVM works, and it just like raises the knowledge of like the average front end dev, and then makes your experience, someone like yours experience better, like working with front end devs who like otherwise would be like clueless on this stuff.
for sure, man, for sure. No, really good points. And yeah, what I'm actually gonna use Tevm for, as I've said before, when when you have especially heavy math stuff,
Mm-hmm.
that you have to. I rewrote it in JavaScript, but it's basically only an approximation. You never
Yeah.
get it exact. And
Mm-hmm.
what I actually did in the past was just take out this piece of math, put it in a contract, and make it a view function that I call into from the front end,
Yeah.
which you can do, but your infura bill just goes through the roof. So actually, just implementing it in Tevim is locally is pretty cool. I'm
Yeah.
surprised I've
Yeah.
never heard of this before.
Yeah, yeah, that's actually like I call that. I need to actually put that in the docs because it's one of the best use cases. I call that bring your own view function because we've all had the
Hmm.
experience of like using
Yes.
like a third party contract and wishing they had a view function.
Yeah.
Um, and yeah, Tevin just like it's basically just using storage slots. I guess like one last thing I just want to mention is that Tevin also has like tracing capabilities. Um, So this is like another like I didn't document it yet, but this it's in here. So I can do like EVM dot on, I think it is. Yep. And like in here, like what I can do is I can do two things. I can basically like console dot log, and this will console log like every single step that EVM takes. It might not be called on, it might be called something different, but this API exists, just trust me. You can like console log every step the EVM takes, and you can even like modify it if you want. If you want a step to do something else, you can do something else. If you want to get, yeah, then you dove into the lowest level, like here you're learning about like what the different like op codes are of the EVM and stuff like that.
Hmm.
That you can actually get that low in Tevin, which is cool. And then also, I'd be remiss if I didn't. I haven't I mentioned Veeam a lot, so like the two I want to just like call out like everyone who's really I like built on top of here. So I mentioned Veeam a lot. VM is definitely like where the API came from and where like a lot of the patterns of Tevin come from. In terms of like the raw like EVM code, most of it is like custom built by me because it's being built to be more like Anvil than like a full Ethereum node. But a lot of it's coming from a project called Ethereum JS, which is from the Ethereum Foundation, which they have like the same packet structure as me. So they have like their EVM interpreter. My EVM interpreter is pretty much just theirs. Like it barely touches the code. Everything else is pretty custom because um, I'm supporting like Anvil like things like impersonation, and I'm supporting like being able to like run scripts and being able like all that stuff required me to build like my own state manager and my own blockchain and all that stuff. But even that stuff is just building on top of the same interfaces as Ethereum JS. So yeah, I definitely wanted to call them out. And they've also been extremely helpful to me, like as like a front end developer noob who really was like building this and I wasn't qualified to build it. Like they've been very helpful at like when I run into something that's just like completely going over my head, at like kind of pointing me in the right direction or explaining why like this certain thing is true. And yeah, yeah, just shout out to them.
Nice. Well, listen, man, this is a great project. I'm surprised I've never heard of Tevin before we talked. But I'm gonna definitely like the bring your own view function. That's just such a good name, man. Like you definitely have to put that in the docs. I will use that for sure. So yeah, I'm gonna put the GitHub repository in the description down below. Will, thank you very much for doing this, man. This was a lot of fun.
Thank you. Thank you for having me.
Awesome, guys. Then thanks for tuning in, and I'll see you in the next one. Bye-bye.